Hello and welcome back to our NC4 laser how-to series. Today we are answering the question, can you measure a tool larger than the NC4 units? So I welcome back Iain, who has all the technical knowledge and the know-how when it comes to the NC4. So Iain, it can't be possible, can it? Surely you'll just mill the heads off the NC4 units.
No, it's possible. You simply have to use our off-center tool measurement cycle.
Off-center measurements? Okay, tell me more.
Well, we have cycle 9868, which is designed for situations where the tool diameter is bigger than the gap between the NC heads. All our other cycles come down on center before commencing measurement, but with this cycle, the tool is offset at the beginning and remains offset for the duration of the cycle.
So apart from it being off-center, this cycle measures the length and the diameter just like our 9862 cycle. So this is part of our standard software package?
Yes, 9868 is included in our standard package.
Okay, this might seem like a silly question, but why can't we just use a unit with a larger separation, as we do offer various sizes?
Well, first of all, our smaller units have a smaller footprint and therefore take up less space on the machine table. Secondly, the smaller units have better metrology than the larger units. Repeatability is slightly better, and when we're undertaking some of the more complex tasks, such as measuring very small tools, measuring single point boring bars, or measuring corner radii and edge checking or profile checking, results are more consistent with a smaller unit. Thanks to this cycle, you're able to benefit from the advantages of a smaller unit while still being able to measure your larger tools.
Is there anything else our viewers need to know about this cycle?
Yes, you need a couple extra inputs with this cycle. You need to enter the nominal length and the nominal diameter. They are compulsory inputs.
Entering a nominal diameter is something we've seen on other cycles, but this is the first time I've seen a nominal length being entered. Why do we need this?
Well, the nominal length acts as a safety net. Because we're off center, if the operator entered the wrong diameter, we could miss the beam completely. But with the length entered, we can control the total search distance as the tool approaches the beam.
Ah, of course. If it misses the beam, it'll keep searching until it hits the table.
Exactly. But with this input, we are controlling the distance, so that will never happen.
So on the machine today, we have the NC4 Blue. It's an F145, which has a separation of 85 millimeters. We want to measure two tools today. The first tool is a face mill, 100 mil diameter. We want to measure the diameter and the length. The second tool is a slitting saw. Again, it's 100 mil diameter. We want to measure the length, but to the top edge of the saw. And we also want to measure the diameter too. Now, both these tools are larger than the distance between the heads. So Iain, can we do the face mill first?
Yep, sure. So first of all, we have the program name, G65P9868. Then we have B3, which is measure length and diameter. We have K100, which is the nominal length. R100, which is the nominal diameter. We have A1, which is the RPM flag. And then we have finally the spindle speed, S500.
So before we press cycle start, I see you've got an A input there. We haven't mentioned that before. Is that something that's required for this cycle?
Well, the A input is an optional input, which allows us to bypass the minimum spindle speed check, which means for our large diameter tools, we can run them much slower. However, we only really advise using the A input if you've got a tool with multiple teeth.
Ah, right, okay, thanks. So should we press cycle start now then?
Yeah.
Okay, the tool safely measured. The offsets have been updated in the tool table. It did seem to come pretty close to those heads mines. How do we know what the maximum diameter tool we can measure off center?
Well, that information is available on our data sheets, but also the cycle will make a calculation internally and compute the maximum diameter allowed based on the separation between the NC heads.
All right, so on to our second tool, which is the slitting saw. And as a recap, we want to measure to the top edge of that saw and its diameter. So Iain, it's over to you.
Okay, so we need to firstly edit the tool number, and then I need to change some of the program inputs. So this cycle is very similar to the previous one. I've edited the K value, this time it's 102, and I've added 2 new inputs. The first one is Z, which is the height at which you want the radius measurement to take place, and the second one is W, which signifies that we want to measure the upper edge of the slitting saw.
Okay, great. Should we press cycle start? All right, tools been measured, the offsets have been updated, but can we set tolerances just like our 9862 cycle?
Yes, like our 9862 cycle, we can set tolerances for both length and diameter with the H and the E inputs, and we've covered these in previous videos.
Okay, so before finishing today, I believe there's one last thing about this cycle that our viewers might find interesting.
Yes, although we've designed this cycle for large diameter tools, it can also be used for standard tools if you're looking to save measurement cycle time. The cycle time is saved because the initial long tool, short tool search is omitted, but of course you must remember to enter a nominal tool length value.
Thanks Iain. So that was a 9868 off-center measurement cycle. I hope this has been useful. Please remember to like and subscribe. Happy tool setting.